This video is going to be about partial pressure. So this is the formula for partial pressure, and all that it's saying is that your total pressure that's in your container is going to equal the pressure of each of the different gases added together. So if we had a gas that are those black dots, a gas that are the blue dots, a gas that are the red dots, they each exert their own amount of pressure. So when we add all of those together, we'll get the total. Now you can have more than 3 gases, you can have less than 3, it doesn't really matter as long as you add all the partial pressures together, that will give you the total. Okay, so let's take a look at a couple of examples. So the oxygen in the tank is exerting 4.05 atm of pressure. So here we have these red dots are representing oxygen, and the blue dots, which I'm going to add, are going to represent helium. Helium is pumped in, so we have a bunch of helium gas particles pumped into the container. And now the total pressure is 20 atm. What is the partial pressure of helium? Okay, so remember our formula. The total pressure is equal to all of the partial pressures combined. So in this particular case, we have the total pressure, which is 20 atm. That is equal to the partial pressure of oxygen, which is 4.05 atm, plus the partial pressure of helium, which we don't know, and that's what we're solving for. So when I'm trying to solve for the partial pressure of helium, because this is being added to 4.05 atm, I'm going to do the opposite of that and subtract it to the other side so that I get partial pressure of helium by itself. So minus 4.05, and whatever I do to one side, I have to do to the other side. Okay, so this cancels out. Okay, 20 minus 4.05 gives me 15.95 atm, and that is the partial pressure of helium. Okay, here's example 2. The partial pressure of hydrogen is 43.7 kPa, helium is 21.4 kPa, and argon is 16.3 kPa. What is the total pressure of all of the gases if all of the gases are mixed? So we have hydrogen gas, 43.7 kPa, helium gas is 21.4, and argon gas is 16.3 kPa. So if we put all of those gases in this container, all we have to do to find the total is to add all of these pressures together. Okay, so 43.7 kPa plus 21.4 kPa plus 16.3 kPa. Okay, so when I add all of these together, so 43.7 plus 21.4 plus 16.3, I get 81.4. So the total pressure is equal to 81.4 kPa. One thing that I want to note is if any of these units are not the same, you have to convert it so that they are all the same before you can add them together. Okay, question number 3. 2 gases are contained in gas bulbs connected by a valve. Gas A is present in 50 liters at a pressure of 411 torr. Gas B exerts 728 torr in 72 liters. What is the partial pressure of the gas B after the gases mix when the valve is opened? Okay, so right now these gases are being separated by this valve right here. It's closed. Okay, now the question is asking what is the partial pressure of gas B going to be after the valve is. Okay, so let's open the valve. The valve is opened and now all of these gases have mixed together. So let's put this off to the side, put the image off to the side so that we can work out this problem. So initially, gas B is exerting 728 torr in 72 liters. That's going to be my initial pressure and initial volume. Okay, the question is asking for the pressure of B after the gases mix. Okay, so what formula we're actually going to use is P1 V1 equals P2 V2. Okay, so even when the gas is mixed with another one, like gas B is mixed with gas A, the partial pressure still stays the same. The difference is that we're changing this into a larger volume. Because remember, initially, gas B was just in this area, okay? But after the valve opened, now it's taking up this whole space, okay? So initial volume, new volume. So P1 is going to be 728 torr. V1 is going to be 72 liters. We're solving for the new partial pressure of gas B, and the new volume is going to be 72 plus 50. Okay, so that's going to be 122 liters. Okay, so now you just solve for P2. So let's multiply these two numbers and then divide 122 to the other side. So 728 times 72, 52,416 is equal to P2 times 122 liters. Let's divide 122 to the other side. Okay, so 52,416 divided by 122, and that gives me 429.64, and we're looking at pressure, and we've been using torr, so this is going to be 429.64